Welcome to the part 7 of the MSP432 MCU's training series. In this section, we will cover the security features of the MSP432. We will take a look at the AES-256 encryption engine provided by the MSP432. We will also take a look at different mechanisms to lock the JTAG access to the device. We will also cover the IP protection feature as well as how to securely update the firmware of the device when the application is deployed in the field. The MSP432 MCU introduces the same AES-256 hardware encryption engine that is known to MSP430 families. This engine is capable of driving 256-bit AES encryption. The hardware engine does not require any CPU activity, so once you load the key as well as the data payload into the engine, the AES can go off and operate in parallel as CPU programming. The AES-256 module support 128, 192 as well as 256-bit key length. It allows for on-the-fly key generation as well as offline key generation. The AES-256 can also be used in block modes such as OFB, ECB, as well as CBC, together in conjunction with DMA. This allows the users to configure a data signal chain, for example, to receive the data through SPI, transfer it over to DMA, transfer it over to AES to perform a decryption or encryption, and then transfer back to another serial communication interface. There are two main benefits for using the hardware engine of AES-256. First is the CPU offload. Since the hardware engine runs in parallel with CPU, you can create an autonomous task, as mentioned before, such as running AES-256 together with DMA. The second benefit is the accelerated performance compared to software implementation. As an example, a 128-bit encryption normally would take around 7,000 cycles in CPU, and when using software implementation, it's now reduced to 190 clock cycles when using the hardware engine of AES. The AES engine is crucial to any security-sensitive applications that requires communication, such as RF, UART communication, or even for field firmware updates. The AES engine is also heavily used by multiple internal engines of the MSP432, such as the BSL or the security features that we will cover in the next slides. From the security standpoint, the MSP432 MCU provides two types of security: the JTAG protection as well as IP protection. So the JTAG protection is a way to block the device completely from any future JTAG accesses. So after blocking the JTAG, user can no longer debug the device or establish a JTAG connection to the device. On the other hand, IP protection is a mechanism that allows software IP vendors to securely lock away a region in the memory with their unique software IP. So this locked region can no longer allow user for read access. However, users can still execute code out of this IP protected region. Think of this as a black box solution that you want to provide software vendor. The MSP432 can also combine the two types of security to provide both JTAG protection as well as IP protection. First, let's take a look at JTAG security on MSP432 MCU. So the JTAG security or the JTAG lock from a user standpoint is very similar to MSP430 JTAG control, where once you lock away the JTAG, no longer debug access is available to the customer. So first off, when a code is developed and loaded into the flash, you can then invoke this JTAG lock mechanism to prevent further debug access. The device is then locked away from external accesses, while the application code can still access any memory areas within the device. The only way to regain access to a device that is locked from JTAG access is to go through a mass erase or factory reset. This is a procedure where the entire flash memory of the device is completely wiped out before the access is reopened to the device. This ensures that any sensitive software or application code is completely wiped out and prevented from further access. So developers can actually use this factory reset feature by going through the IDE option as well as through one of the examples that we provide below. For a device that is locked from further JTAG access, the firmware of the device can still be updated in the field using a BSL. At this point, the user has the option to use a secured update as well as a non-secure update, and we will cover this in the next slide when covering the BSL portion of the security. Moving on to IP protection. As mentioned earlier, IP protection is a mechanism that allows software IP vendors to securely provide their unique black box IP solution, preventing the end users from reading out the secret IP but still allowing the customers to execute these IPs. It is done so by preventing find further read accesses in a debugger or read accesses from the customer's application code itself. However, customers can still safely invoke the functions within the IP protected zone. The MSP432 MCU supports up to 4 IP protected regions. So think of a scenario where there are 4 software IP vendors, with the first one program and lock away their first IP protected zone and deliver to the second IP vendor. The second IP vendor can execute from the first protected zone but cannot read out the content. They can then program the second IP zone and so on and so forth. At the end, the end customer, the end user, can execute any of the functions that are provided within these 4 IP protected zones, but they can no longer read out any of the content. Similar to the JTAG lock, the MSP432 also enables a mechanism that allows customers to update these individual IP protected zones out in the field without compromising the content of the firmware that is being updated. So this is how device security is set up on MSP432. And this works for both JTAG and software lock configuration or IP protection setup. You can also use the same mechanism for BSL configuration as well as to update the firmware. And the mechanism is called boot override. What it does is that there is a special region in the memory called flash mailbox where one-way communication can be transferred from the user or the application code to the boot code. And once a message, in this case a configuration message, is being programmed into this flash mailbox, user can issue a device reboot reset, and then the boot code can take over, read out the content of this message, and perform the necessary task to either lock the device from further JTAG access or to configure the IP protect zone with or without a password. Once this operation is completed, the boot code will program back into the memory with the status of the operation, whether success or failure. And once that is done, the device is now locked away from JTAG access, the IP protection zone is completely protected from further read access, or the BSL is configured to the way the customer prefers. The same mechanism can also be used for updating the firmware in the field. Again, in this case, since JTAG is no longer possible, this flash mailbox can still be programmed by the BSL as a way to transfer secured messages from the BSL host to the device to the boot code to program the new firmware into the memory. There are multiple layers of security that are embedded into the firmware update mechanism of the MSP432 devices. At the first level, the bootstrap loader BSL is already protected by a specific password. So in order to gain BSL access to the device, whether the device is secured with JTAG or IP protection or not, a password must be provided by the BSL host. When the device is locked from JTAG and SWD access, the user has the option to provide an encryption key. This encryption key will allow the BSL to encrypt the payload before programming and transferring the data over to the device. So the key is only shared at the time of initial firmware programming, and then the BSL host must encrypt the payload with the same key so that the BSL communication can be secured and protected from any snooping on the BSL line. Once the encrypted payload is transferred over to the device, the BSL must then invoke the boot override using the flash mailbox as we just talked about. So this boot override mechanism can then read out the message from the BSL and then decrypt the payload with a pre-aligned encryption key and program the decrypted image of the firmware to the device flash memory. Once it is complete, the device can then reboot and execute with the new firmware. The IP protected zones can also be updated given that an encryption key is provided. This is very crucial because it allows for IP vendors to securely provide their field firmware update without their customers getting access into the actual content of their firmware. So again, the encryption key must be shared at the beginning of time when the IP protected zone is being programmed initially. The IP vendor can then provide the payload that is already encrypted with the key to the end user. The end user will then use BSL to access the device and transfer the encrypted payload over the device. Again, the same boot override mechanism using the flash mailbox can be invoked, and then the boot code can securely decrypt the payload with the same encryption key, reprogram into the IP protected zone. Throughout the entire process, no one other than the original IP vendor has access to the key. After the operation is done, the device can go through a reset routine, and now the new IP protected firmware can be used. Device security as well as IP protection are really complex topics. After going through the high-level overview of security features on MSP432 MCU here in this video today, we highly recommend you to research further by going through different application notes and software examples made specifically to demonstrate how to enable software security on MSP432, as well as how to configure security updates or BSL programming on MSP432. So all of these resources are available inside MSPware. Below is a screenshot of where you can find the relevant application notes as well as software examples inside MSPware. With that, we have concluded the part number 7 of the MSP432 MCU training series. Thanks for watching.